So I'm just going to go over questions number 15 and 17 from the '05 homework, chapter 4.3 from the Stewart calculus book. So that's to find the increasing, decreasing regions, the max min points, and the concavity and inflection on these graphs. Okay, so I want to find the derivative. So I end up with 2e to the 2x minus e to the negative x. That's my first derivative. I want to find out where this is equal to 0, so then I need to solve this equation equal to 0. So I'm looking for the solution to this equation. E to the 2x is equal to 1 over e to the x. So this becomes e to the 3x equals 1/2. Okay, so I'm just going to multiply, essentially just cross multiplying here. So then I put it into the log form. Log 1/2 is equal to 3x. So x is equal to 1/3 log 1/2, or log of the cube root of 1/2. Okay, so approximately, if I plug this into my calculator, so I'm going to take the log of the cube root of 1 divided by 2. Okay, so I'm going to end up with a value of negative 0.23. Okay, and y equals, when I plug that into my back into my original equation, I end up with e to the 2x minus e to the negative point. Oops. E to the negative x. Okay, so I'm getting 0.001, or basically 0.002. Okay, so then on my chart here, I'm going to start a slope chart. I have at negative 0.23, I have a 0. If I test the slopes on both sides, okay, if I test positive 1, I'm going to end up with 2 minus, in fact, I'm just going to choose 0. I'm going to end up with positive. Okay, so it's going up in this direction. Okay, if I choose negative 1, I'm going to end up with, looks like negative 2 divided by e squared minus e, so I'm going to end up with a negative value here. So it's going to be going down like that. So there's my min point on that graph. Okay, so it also asks for concavity and inflection. Okay, so I want to find my second derivative. My second derivative works out to be 4e to the 2x plus e to the negative x. Again, I want to solve for where this is equal to 0, so I end up rearranging this. I get e to the 3x is equal to 1 over 4. Okay, and then solving this equation, I get log 1 over 4 is equal to 3x. Again, I get divide by 3, so I'm going to put that inside the log as a cube root, 1 over 4. Okay, so it's just some algebraic rearrangements to get from here to here, and then solving for x. And again, plugging that into my calculator, I'm going to get log of the cube root of 1/4. Okay, that gives me negative 0.46. Okay, so this is my f prime chart. I'm going to do down here I'll do an f double prime. So at negative 0.046, I have a 0 concavity. Testing that equation on at x equals 0, I'm going to have 4 plus, that's going to be positive concavity here. Okay, if I test a negative here, I'm going to get a negative number here. So let's try -1. Here I'm going to get E4 divided by E squared plus E to the, what's that going to be? Oh, that's going to be, looks like it's going to be positive as well. Okay, so, I think I made a mistake on here. Okay, just going back a bit here, this is not going to solve. Okay, let me just go back on that because I just realized that that is a positive. So in this case, this will never equal to 0 because there's no solution. So f double prime x is not equal to 0 because exponential is positive and positive will not equal 0. Okay, so there is no 0 point. Okay, so if I test this, it's concave up at any point. Okay, so if I plug in an x, there's no change of concavity here. There's no point where I would expect there to be a non-differentiable point or a critical point that I need to look at. So it looks like this graph's just going to be entirely concave up. And it's going to have a point at something like that. Okay, so there's be my point at -0.23 and 0.002 as my minimum point.